Hey guys, this is just a quick note on AlphaEvolve. I've seen a lot of videos recently that are sort of hyping this up to be a generalized kind of research agent that's able to come up with new things, new scientific and technological advancements all on its own. Um, but yeah, I think this is pretty much overhyped. And if you look at the specifics of what it can do, which we're going to just quickly go through here, there's only a few relevant examples. You can see that basically it is not very general in any case. And it's essentially um, usually just optimizing and making some usually like fairly trivial changes, um, and basically testing its like predictions against a like very robust evaluation metric and just throwing things at the wall until it sticks. So let's look at a few of the examples, right? So the first one is a faster matrix multiplication for 4 times 4 matrix multiplication, right? And it's basically able to do it in one operation less than the previous state of the art, right? But what what you would think they did is that maybe it like thought about it a bunch, right? Like in quotes, thought about it a bunch, and then outputted the algorithm just on like in terms of words or in terms of like a computer algorithm. But no, it does not actually output the actual matrix multiplication algorithm. What it actually does is modify a heuristic search algorithm, basically like another optimization algorithm that then produces the algorithm in question. So what it actually has done is essentially add these things. Like this is a hyperparameter search, right? It basically has added a few more hyperparameters to an existing optimization algorithm, right? A like more classical optimization algorithm, and it's added these sort of hyperparameter searches. It's added some tricks like adding noise or adding batch dimensions, right? Or adding some debugging functions and things like this. And that's how it was able to, after repeated tests against a very robust evaluation metric, which in this case is simple to formulate, right? Because it's like how many operations did it take to perform the matrix multiplication, and was it correct, right? So that's how it was able to quote unquote propose a new matrix multiplication algorithm. So and we can see another few examples, right? So in terms of the mathematical constructions here, finding basically better ways to pack different shapes inside of other shapes, right? And packing of spheres and things like this. These are not like proof-based like kind of problems, right? This is still not doing math in the sense that when most people think about doing math, it's like proofs and understanding why certain things work. But this is more, there is a heuristic search algorithm, a more classical algorithm that already is able to make progress into solving this problem. And what AlphaEvolve does is change the hyperparameters, and just sort of like change the searching parameters of this algorithm, and sometimes make a few other changes about how the search is done as well. um, yeah, like you see here, right? It's mainly the AlphaEvolve's ability to evolve heuristic search algorithms, right? So you can train another model, right, a more classical model to be able to do this kind of thing, and that's only possible for very specific problems where evaluation is very easy, right? And then search is also very easy, right? I mean, easy as in like you can basically program something to search the space, right? So something that's fairly constrained. Um, so, yeah. Let's look at another one. Yeah, also for the math problems, like they had to invite some pretty top guys over here to try to like formulate the problem for AlphaEvolve. Otherwise, it would have been fairly difficult to actually make the original program for AlphaEvolve to iterate on. Um, yeah. Another example they give is some real world applications, right, where they have, they used it to improve their basically Google server scheduling mechanisms. But unfortunately, this is like very restricted use. Like it's not like it analyzed the entire scheduling apparatus and then made some strategic decisions and strategic changes. Like no, it was very specifically used for one part of the whole entire structure, which is a function that assigns like a priority value for machines given a particular incoming job, right? And it's like a very simple operation, right? The number of inputs can be seen in this function, right? Very few number of inputs that are possible, right? And it basically has evolved a heuristic that looks exactly like this. I have simple heuristics are sometimes powerful, but it does give you an idea, right? That this is not like a huge strategic change. This is like a very small part of a system that was very well specified. And they were only able to do this because they could simulate the functioning of the scheduler. They had a predictor that would tell you if you made a particular change, how would this impact the functioning of the system, right? Which is a luxury that in most open problems that people do not have. Yeah. So there's a few more examples of kernel speedups. Again, something that is very measurable. And then hardware design, which like is a bit more complicated process, but still there's a lot of precision involved. So people already have written a lot of test cases for this stuff to guarantee correctness. And also whatever change it discovered was discovered by some downstream tools as well. Like basically it is improving on the ability of people to iterate on these problems with already robust test cases and with already robust search algorithms as well. So the only so apart from these, there is one instance where AlphaEvolve was able to write something from scratch essentially, which is sort of like a kernel, a flash attention kernel optimization, right? But that is also still writing an algorithm in some sense. But yeah, I think this is like slightly more impressive. And I don't want to like sort of dismiss the entire project or paper. Right? It is like a fairly impressive application of language models at scale that did do something, right? That did do something useful. So if I'm gonna go back to my green notes here. Yeah, it is able to autonomously discover patterns, even though it's iterating against a very clear metric, right? And it is also, doing this iteration using a fairly flexible kind of approach, right? It could write algorithms, it could write the code itself, right? It could even potentially just give you the answer, although that's like somewhat rare in this paper, that we don't really see that. Like these are all tasks that would take humans a non-trivial amount of time to do, right? And it's able to automate that process, which is definitely something that's valuable in terms of the amount of work that's being produced. And also, even though the final proposal must go across like very significant like tests to ensure that it's correct, this is true for basically a lot of things that are on a large scale, right? Like if something is very mission critical in a big company, it will have tests already written for it, maybe less tests than you would need for AlphaEvolve to be able to work on it, but still there's a solid foundation, and if you can modify it so that the criteria is aligned, right, and the criteria will not be gained by AlphaEvolve, then it can be used to significantly speed up the search process to improve the metric. And then yeah, lastly, it did do this optimization of compiler generated code, and that was from scratch. That was not using a heuristic search algorithm that it writes. So this is promising. I mean, like in terms of code, being able to optimize code is very easily sort of testable if you have the test cases and you have the profilers that's able to measure how fast your code runs. So it's very interesting. Yeah. But yeah, but I generally say, like, I mean, there's just too many videos that are just trying to highlight how this is like a massive breakthrough, and it's not really. Like, there's been academic works that have built on top of this, well, on top of the ideas used in this, and have introduced more complicated ideas much earlier. It's just that this paper put it into practice because they had the backing of obviously a big company, right? So if you look at the related works, they even basically admit this, where they say that a bunch of other papers have covered similar sort of setups, right? Like the AI co-scientist and some other works. Yeah. Yeah, if you're interested, do read the actual paper, which is on the Google DeepMind website and such. All right, see you guys. Bye.